Hi, and welcome to video 2 for section 3.2. This is the second of 4 videos. As you can tell from the timestamp, this is a pretty short video, but it's important. I wanted to keep it separated out so if you have to go back and reference it, you'll have easy access to find it. This video, we're going to be talking about the real zeros of polynomials. And another way that you might hear this called is the roots. The roots of a polynomial, excuse me, the zeros of a polynomial, the real zeros of a polynomial, all references the same thing. We have the following definition. If P is a polynomial function then C is called a zero of P, or is called a root of P, if P of C is equal to 0. So basically, if I have some polynomial function and I ask you, is C equal to 1 a root of the polynomial or a 0 of the polynomial? Well, you would plug 1 into the polynomial function, simplify it, and if it simplifies to 0, then yes, it's called a 0 or it's called a root. A note about the zeros or the roots, the x-intercepts, because if we wanted, if you remember at the end of the second video for section 3.1, I referenced you guys, okay, remember how to find an x-intercept, how to find a y-intercept. To find x-intercepts, what do? We set the whole function equal to 0. So if I set the whole function equal to 0 and solve for x, that gives me the roots or the zeros. That's what we're doing. So note the x-intercepts of a graph are the zeros of a function, or are the roots of a function. So, let's look at a quick example here. This will wrap up this video. So we want to find the zeros of the polynomial function P of x is equal to x squared plus x minus 6. So again, how do we figure this out? It's the same way we figure out the x-intercepts, which is to say what? Whoops. X squared plus x minus 6 equals 0. So if we can figure out where these guys are equal to 0, that'll let us know the roots or the zeros of this polynomial function. This is why in chapter 1 we were solving these equations, factoring, using zero property rule, or using the quadratic equation. So this guy will factor nicely for us, and we get what? X plus 3, x minus 2. That means x plus 3 is equal to 0. X minus 2 is equal to 0. So x minus 3 and x is equal to positive 2 are the zeros, or are the roots of this polynomial function, which means it's also the x-intercept. So if you were to graph this thing, the graph is going to go through the x-axis at these points. So let's just draw a quick sketch. So I know it's going through at negative 3. I know it's going through at positive 2. And what's the end behavior look like? Referencing back to the first video. Well, it's x squared. That's like a parabola. And it's positive, so it's pointing up. So I know this thing's somewhere here. And it ends up here. So it looks something like that. It's a parabola that crosses the x-axis at -3 and +2. And that's the kind of information we're going to be using to start graphing more complex polynomials. And that's what we're going to be doing in video 3. So that wraps up video 2, a definition of what is a zero, how do we find it by setting the polynomial equal to 0, finding the roots of that polynomial, and that gives us these zeros. So come on back and we'll look at how do we sketch some of these polynomial functions.